Hello and welcome to the flip lesson on the basics behind the law of signs, minus the ambiguous case. So in geometry, you learned about the law of signs, and it turns out that what you learned in geometry is not actually the complete lesson on the law of signs. Sometimes you run across this really funny situation known as the ambiguous case, where maybe the law of signs turned out not working, and there's a reason for that. Or maybe the answer you got is only part of the answer, and that's the ambiguous case, and that's coming up in our next lesson, so stay tuned for that. But in today's lesson, all the triangles we work with, those are all problems where the ambiguous case would never show up to begin with, and we're okay doing it just with the basic law of signs. So let's get started. So first of all, this is what the law of signs says. It says, suppose you have any triangle at all, triangle ABC, doesn't have to be a right triangle, where little a is the side opposite angle A, little b is the side opposite angle B, and little c is the side opposite angle C. It turns out that this proportion will always hold true. The sine of angle A divided by its opposite side is always going to equal the sine of angle B divided by its opposite side, which will always equal the sine of angle C divided by its opposite side. Basically, the law of signs lets us use trigonometric ideas, like sine, with non-right triangles. Now, our focus in this video is to see how the law of signs works. The next video will show us why the law of signs works. But let's get the mechanics down first before we explore why this is working out. So, before we get started, let's see when you use the law of signs. Basically, there are just a couple different scenarios of when you can use the law of signs. And feel free to pause this video and write these down. Well, welcome back. Hopefully you paused the video and wrote this down. But let me just summarize this in a very, very basic way. You can use the law of signs anytime you have a triangle and you know both an angle and the side opposite that angle. Anytime you have an angle and the side opposite that angle, it's a great candidate for the law of signs. So let's jump in and do an actual problem. Here we go. Let's say we have this triangle right here. Now, first of all, is this a good candidate for the law of signs? Well, I notice it is not a right triangle. If it was a right triangle, I would just use tangent or cosine or just basic sine. But this is not a right triangle. So I'm going to try the law of signs, and I notice I do have both an angle and the side opposite that angle, so this is telling me let's do it. Solving the triangle means we're going to find every single side and every single angle within that triangle. So I think the first thing we're going to do is the easiest thing, and that's we're going to find angle C. So basic subtraction gets us angle C, and look at that. We have it right here. It's 39 degrees. Well, now that we have angle C, let's go after some of the sides. And the side I'm going to go after first, although it doesn't matter, is side A. So let's find side A using the law of signs. So the first thing I do is I identify my anchor. And the anchor is where we have both an angle and the opposite side. So in this case, when I go to fill in my numbers in the law of signs, I used 88 degrees and 7 because that anchors the problem. Now, to find side A, we need the angle opposite A, which is 53 over A. And now it's just a matter of some algebra. I think the first obvious thing we're going to do is cross multiply. And then to solve for A, we're going to divide both sides by the sine of 88. And there we go. We have A in all by itself. Ooh, wait a minute. Do you hear club music? Well, I think you do, because it turns out that some kids belong to this shortcut club. Some kids can skip that step entirely and go from here directly to here. And it turns out that for each problem, I need to see three things. I want to see the initial law of signs. I want to see what you put in your calculator. and I want to see the answer. So let's go to our calculators. So there's my calculator. Whoops, look at this. I'm not in degrees mode. I better switch over to degrees mode. There we go. All right, we're in degrees mode. And I'm going to type this in. Let's see here. I'll use my shortcut fraction key. 7 times the sine of 53 divided by the sine of 88 equals that. 5.59 blah, blah, blah. So there's my value for A. All right, so now that we found side A, I can put that here in my picture. And the only thing left to find is side C. So let's go back to the law of sines. I'm going to use my anchor, sine of 88 over 7. Again, 88 and 7. Those are exact measurements that I was given. But this time on the right side, we have the sine of 39 over C. Now, if you're a member of the Shortcut Club, write down what comes up next. All right, here we go. Did you get that? If you did, you're part of the Shortcut Club. And once we dump that in our calculator, and I'll let you do that, you get C is about 4.41. We have solved this triangle. All right, let's move on and do one more problem. So the last problem is this. Again, we have here a great candidate for the law of sines. There's no evidence that this is a right triangle. We do have an angle, and we do have the side opposite that angle. So let's dive in and see if we can solve this using the law of sines. This time, there's not an easy one to find. You know, so I think I'm just going to jump right in with the law of sines. Here's my anchor, and I think the first thing we have to get is angle Z. So let's see if we can do that here. Let's see. So the sine of 70 over 9 equals the sine of Z over 5. Now, cross multiplying, we get 9 times the sine of Z, that way, equals 5 times the sine of 70. Okay, we're going after Z. We got to get Z all by itself, so I think I need to get rid of that 9. So dividing both sides by 9, we end up with the sine of Z equals 5 times the sine of 70, all divided by 9. So we haven't quite solved this for Z. So to get Z by itself, I'm going to have to take the inverse sine of both sides. So I take the inverse sine of both sides, and that's what I get. Now, believe it or not, there is a shortcut club for this. There are some kids who can skip both of those steps and can go from this initial equation into that. That's pretty amazing. But maybe you belong to that shortcut club. Maybe not. Maybe not. Maybe you have to do the algebra. Let's see. So I'm going to take to my calculator, and I'm going to go ahead and type in the inverse sine of 5 times the sine of 70, close your parentheses, divided by 9. And that gives me about 31.47 ... So let me go ahead and write that down here, and I'll put that here for angle Z. Great. So now that we have X and Z, we can find Y. And that's going to involve some subtraction. Well, maybe let's go to our calculator. To find Y, I'm actually not going to use 31.47. What I'm going to do is I'm going to take 180 and I'm going to subtract 70, and I'm going to subtract that previous answer. So I'm going to type second answer. And that gives me the angle I'm going to use for Y. So this is the value that I'm going to use from all my calculations from now on. As a matter of fact, it might be worth for me to store that value, and I'm going to store that under the letter Y because that's the angle it represents. Okay, so let's come back to this problem. I know Y is 78.53 ... I set up the law of sines using that basic formula. Again, I'm using my anchor, 70 and 9. I'm not using this rounded number. Shortcut club. And then I can type this in my calculator. Now remember, it's not 78.53 degrees, but it is the value we stored in our calculator under Y. So I can go to my calculator. I can type in, let's see what I have to type in. I can type in 9 times the sine of Y over, I forgot what I was typing here, the sine of 70. And that gives me my final value, about 9.39. So y is about 9.39. Well, you have your lesson, so go ahead and get started on the problems that I assigned for homework. Feel free to go back and look at the video again, and if you think you're a member of the Shortcut Club, more power to you. Have a good day.